All right, so ready to dive into some trigonometry.
Always up for a good triangle adventure.
Haha, I like that. You've sent us some textbook excerpts on the intro to trig.
Yeah.
And honestly, there's some pretty fascinating stuff in here, like beyond just the formulas.
Right.
We're going to break down those fundamentals, figure out why these ratios are so important, and see how they pop up in some pretty unexpected places. What do you think?
Sounds like a plan. You
Yeah.
know, it's funny how trigonometry often gets boiled down to just memorizing SOH, CAHTOA,
Right. Right.
but it's so much more dynamic than that.
Yeah.
It's about understanding the relationships between angles, distances,
Yeah.
and how those relationships can help us, I don't know, understand the world around us.
It's like having a secret decoder ring for geometry almost.
I like that.
Yeah. The textbook defines trigonometry as the study of relationships between the sides and angles of a triangle,
Okay.
which I'll admit sounds a little dry at first.
Yeah.
But when you think about it, triangles, they're everywhere.
Everywhere. Absolutely. And think about the word trigonometry itself.
Okay.
It comes from the Greek words for three, sides, and measure.
Oh, wow.
Like ancient geometry got a cool Greek name upgrade.
I love that. And the history goes way back. We're talking ancient Egypt, Babylon.
Oh, yeah.
These civilizations were using these concepts to, like, measure distances in space.
Incredible.
Way before telescopes. Can you imagine trying to chart the stars just by looking up and doing some math?
That's amazing. It really highlights how powerful these concepts are.
Yeah.
You know, the textbook mentions a student trying to figure out the height of the Qutb Minar.
Oh, right.
Imagine that. Instead of climbing the entire structure with a measuring tape,
Oh, my gosh, yeah.
they could use trigonometry to figure out its height.
That's incredible. I'm picturing someone standing at the base of this massive tower, like maybe using a simple tool to measure an angle.
Exactly.
And then, boom, they've got the secret to its height.
Exactly. It's like a superpower.
It is. And there's more. The chapter also talks about this girl trying to figure out how wide a river is
Right.
just by looking at a flower pot on the other side.
Oh, wow.
It shows you can use these principles in everyday situations.
Absolutely. It's all about triangles, really. Even that hot air balloon example, the one showing how to determine altitude, it all comes down to understanding the relationships within a triangle.
Fascinating.
And those relationships are where our friends, the trigonometric ratios, come into play.
Okay, so let's talk about those ratios. Cosine, cosine, tangent. I mean, those terms can sound kind of intimidating.
Yeah, they can be a little bit scary at first.
Can you break them down for us a little?
Absolutely. So picture a right-angled triangle, right?
Okay.
You've got your opposite side, your adjacent side, and the hypotenuse.
I got it.
Each trigonometric ratio, sine, cosine, tangent, and their lesser-known friends, cosecant, secant, and cotangent, give us a way to describe the relationship between those sides and a specific angle within that triangle.
Okay, so if we know one of those ratios, we can figure out the others.
You got it.
Really?
And the text gives a fantastic example of this.
Okay.
It uses the Pythagorean theorem,
Oh, okay.
you know, that old friend from geometry class,
Yeah.
to show how if you know the tangent of an angle,
Right.
you can unlock the secrets of all the other ratios.
Wow. Okay, so Pythagoras' theorem, the one that tells us about the relationship between the sides of a right triangle, suddenly becomes this essential tool in trigonometry.
Absolutely. It's all connected.
It's amazing how these concepts are so interconnected.
Absolutely. And it gets even more intriguing when you start looking at special angles and their trigonometric ratios.
Oh.
Angles like 0 degrees, 30 degrees, 45 degrees, 60, and 90.
So those angles are special for a reason?
They are. They pop up all the time, especially when you're dealing with common geometric shapes. Imagine working with equilateral triangles, for example.
Right.
Knowing these special angle ratios can really come in handy.
Right. It's like having a cheat sheet for geometry, but one you actually understand.
Exactly.
Okay, so we've got these special angles. Are there any other important angle relationships we should know about?
There are. Have you ever heard of complementary angles?
Remind me.
So complementary angles are angles that add up to 90 degrees.
Okay, right.
And guess what? Their trigonometric ratios have some fascinating relationships too.
Wait, so by understanding those relationships, we could potentially simplify some calculations, like find shortcuts.
Exactly. It's all about finding those elegant solutions. In fact, the textbook gives a great example where you can evaluate an expression with tangent and cotangent much more easily by using this principle of complementary angles. It's pretty neat.
That's amazing. It's like learning the secret shortcuts through a maze. This is already blowing my mind, and I have a feeling we're just getting started. This is like unlocking a whole secret language of angles. But the chapter keeps going. It goes on to introduce trigonometric identities, these equations that are true for any angle you plug in.
Yeah, it's like the fundamental laws of the trig universe almost.
Right.
These identities give us powerful tools for, playing with expressions, simplifying things, solving equations.
Okay, so the textbook, it really spotlights this one identity, cos A plus sin A equals 1.
Yeah.
It seems so simple.
Right.
What's the big deal about that one?
Well, that one right there, that's the Pythagorean identity. It's like the cornerstone of trigonometry.
Right.
And it comes directly from the Pythagorean theorem.
Oh, wow.
Again, showing how deeply geometry and trig are intertwined.
So we've got this identity, it's rooted in geometry, and it unlocks all these other trigonometric relationships.
Exactly. It's amazing, right? And the textbook really stresses how useful these identities are for simplifying expressions, which can make solving problems way easier.
Yeah.
It's like having a master key that can unlock tons of doors.
I'm starting to see why trigonometry has fascinated, mathematicians and astronomers for centuries.
Yeah, absolutely.
It's like a puzzle, but the pieces are these angles and ratios, and if you solve it, you understand the universe.
I love that analogy.
Yeah.
And speaking of understanding the universe, the textbook focuses a lot on right-angled triangles. But trigonometry is way more powerful than that.
Wait, so all this we've been talking about, it applies to other shapes and situations too?
Oh, absolutely. That's where things get really interesting.
Mm.
But before we go too far beyond right-angled triangles, are there any questions about the basics we've covered so far? Anything you want to revisit before we, expand our trigonometric horizons?
It's like we've been exploring this whole hidden world of, triangles and ratios.
Yeah.
And now you're saying there's like a whole universe beyond right angles.
Exactly. Tell me more.
That's what's so cool about trigonometry.
Yeah.
It's not just stuck in a textbook.
Right.
It's a tool people use in so many fields.
Okay.
Architecture, engineering, even music and art.
Hold on. Music and art.
Yeah.
I have to know more about that.
Yeah.
How does trigonometry fit into something creative like that? Well, think about sound waves.
Okay.
They're all about vibrations, frequencies.
Right.
And those can be represented as waves, right?
Hmm.
And waves, they have that cyclical repeating nature,
Okay.
which we can actually describe using trigonometric functions,
Wow.
like sine and cosine.
So when I'm listening to my favorite song, I'm basically experiencing trigonometry.
Kind of, yeah.
That's amazing. Okay, but what about art? How does that work?
Think about perspective.
Okay.
In drawing and painting, creating that realistic depth
Yeah.
on a flat surface, it often relies on understanding angles and proportions,
Right.
which are very closely tied to trigonometry.
So artists are kind of using these principles to create illusions.
Exactly.
That's so cool.
Yeah.
It's like trigonometry is this hidden ingredient that makes art come to life.
It's a different way of looking at it.
It really is. It's
Yeah.
incredible to think that these concepts we've been talking about, they have such a wide impact on our world.
It's true. Trigonometry is more than just formulas.
Yeah.
It's a way of understanding these relationships that shape our world,
Wow.
from the stars to the music we listen to.
When we started this deep dive, I thought we were just going to be skimming the surface.
Yeah.
Maybe dusting off some old geometry knowledge.
Right.
This has been a journey.
I'm glad you think so.
It has been fun.
We've uncovered history, explored how it's used in the real world, even delved into the elegance of trigonometric identities.
He's covered a lot of ground.
And we've seen how trigonometry helps us measure incredible distances, understand the nature of sound, and even create art that plays tricks on our eyes.
It's pretty remarkable when you think about it.
It is. And the best part is, this is just the beginning.
Oh, definitely. There's so much more to uncover in the world of trigonometry.
Exactly. So, listeners, we're going to leave you with one final thought, something to think about.
Okay.
We've talked about how trigonometry applies to right-angled triangles,
Right.
but as we've been hinting at, there's a whole lot more to it.
Yeah.
What other areas of math, science, maybe even art
Might use these principles? What other problems can you solve with the power of trigonometry? We encourage you to take this knowledge and keep exploring, because the more you learn about trigonometry, the more you start to see it's not just about triangles and ratios. It's about unlocking the secrets of the universe around us.
I like that.